In early August 2025, NASA made a move that left scientists speechless. The James Webb Space Telescope, a machine built to study the birth of galaxies billions of light-years away, suddenly broke its schedule. Its mission was clear: to look outward, never inward. But then something entered our solar system that changed everything. A faint object appeared. Small, silent, but moving in ways no one could explain. They called it 3iatlas, and at first it looked like a comet. But within days, telescopes began reporting impossible readings. Its light was pulsing, its orbit was shifting, and its chemistry didn't match anything known. For NASA, ignoring it wasn't an option. So they did something they'd never done before. They overrode Webb's mission, risking billions in equipment and years of research to chase one mysterious traveler from another star. What did they see? And why did this one object force humanity's most powerful telescope to rewrite its own rules?
The James Webb Space Telescope doesn't improvise. Every hour of its mission is planned months ahead, its instruments tuned to the faintest galaxies at the edge of the universe. But on August 6, 2025, the plan fell apart. Ground telescopes in Hawaii and Chile detected something unusual, a comet-like object accelerating in strange bursts. Its light contained traces of metals that didn't belong in normal comets, and its path was shifting in real time. If Webb didn't move immediately, the chance to study it would be gone forever. Normally, a change like that would take weeks of debate, but this time there was no time. Within hours, NASA scientists made the call, a full emergency override, something done fewer than 5 times in Webb's history. At 2:17 GMT, the command was sent. Webb's mirrors turned, humming as they locked on new coordinates. And then, for the first time, it wasn't looking back in time. It was watching something happening now. The first images were rough but undeniable. The object glowed brighter than expected, its tail faint and unnatural. The team had taken a risk, and what Webb found would change everything we knew about comets. Every comet begins the same way. Ice warms, water vapor escapes, and sunlight creates a glowing halo. That's the rule. But 3iatlas didn't follow it. When Webb's spectrograph began collecting data, water, the fingerprint of every comet, was barely there. Instead, the readings showed something completely different. Carbon dioxide dominated the signal, outnumbering water 8-to-1. No comet had ever shown that ratio before. Even more shocking, Atlas was still 6 astronomical units from the Sun, so far that sunlight should have been too weak to wake it up. Yet it was alive, venting massive clouds of gas as if something inside it had turned on too soon. And the tail, it didn't glow like others. There was no dust, no golden shimmer. It stretched like a ghost across the stars, thin and transparent, made entirely of gas. It wasn't shedding ice and rock, it was burning from within. Some scientists believed it came from a star system where water was rare but carbon was plentiful, a birthplace utterly unlike our own. Others whispered that maybe the activity wasn't natural at all, that maybe something inside Atlas was driving it. Whatever the cause, one truth was clear. This wasn't a comet shaped by our solar system. It was something born in another world and behaving like nothing we'd ever seen.
The next discovery was even stranger. When Webb analyzed Atlas's light deeper, it found something no scientist could explain: nickel without iron. In space, those two metals are inseparable. They form together, fuse together, and vaporize together. But in 3iatlas, iron was gone completely. At first, the team blamed calibration errors or background contamination. But after rechecking the data and confirming it with observatories in Chile and Europe, the results stood firm. Pure nickel, shining like a beacon in space, and not a trace of iron anywhere. That shouldn't be possible. On Earth, separating those metals requires high heat, precise chemical processes, the kind used in industrial refineries. Nature doesn't do that on its own. Some proposed that nickel carbonyl, a volatile compound, could vaporize more easily than iron, but only under very specific conditions. Conditions we've never seen in any comet, asteroid, or star system near our own. If true, it meant Atlas came from an environment built on a different chemistry altogether, a place where the rules of planetary formation were rewritten. Others took it further, asking the question everyone was afraid to voice aloud. Could this separation be deliberate, a design, not an accident? Because the more the data repeated, the more it looked intentional. And in science, when something looks too perfect, it usually means someone or something made it that way. Then came the motion, the final crack in everything we thought we knew. As teams tracked the object, its acceleration jumped again, sharp bursts repeating in rhythm. 3iatlas wasn't gliding smoothly through space, it was moving in pulses. Each increase followed the same interval, a steady 7.2-hour cycle, measured with machine-like precision. Natural comets spin irregularly, their brightness flickers and fades. But Atlas's light didn't drift, it beat, over and over, like clockwork. Computer models couldn't reproduce it. Jets of gas couldn't explain it. Even complex rotation simulations failed to match the pattern. It wasn't chaotic, it was consistent. Astronomers began calling it a cosmic lighthouse, sweeping its beam across space in perfect rhythm. And soon, everyone remembered the first interstellar visitor, Oumuamua, discovered in 2017, another object that accelerated without explanation. But where Oumuamua's data was incomplete, 3iatlas left no doubt. It was brighter, more regular, more controlled. Some said it was a natural quirk, a strange coincidence. Others whispered something far bolder, that we might be watching the first machine from another star. And if that were true, then it wasn't just passing through, it was watching back.
By late August, 3iatlas had divided the scientific world. Half called it nature's rarest creation. The other half wondered if nature had anything to do with it at all. NASA and the European Southern Observatory labeled it a high anomaly, not a threat, but something that didn't fit any known model. The label alone meant one thing. Even the experts had no idea what they were looking at. Some believed Atlas was born in a carbon-rich nebula, an alien environment where our rules don't apply. Others, like Harvard's Avi Loeb, argued that separating nickel from iron takes technology, that this wasn't a rock, but a relic. Meanwhile, another concern quietly surfaced. If Atlas's tail, filled with metallic dust and cyanide gas, ever drifted near Earth's orbital path, it could interfere with satellites, telescopes, and navigation systems. A strange irony. The same object that redefined our understanding of the universe might also threaten the very machines that study it. For the public, the debate became more than science. It became a mirror, reflecting how little we truly know. Whether Atlas is nature's masterpiece or something engineered, it reminded humanity of one haunting truth. The universe still writes stories we can't yet read. 3iatlas isn't just a comet, it's a question. One written in light, metal, and motion, and one that humanity may spend decades trying to answer. Maybe it's nature's most mysterious, or maybe it's a sign that we're not alone after all. Whatever the truth is, this single visitor has already changed how we see the universe and how the universe might be seeing us. If you've made it this far, you're part of the few who truly think about what's out there. What do you think? Is 3iatlas natural or engineered? Leave your thoughts below and hit like and subscribe because this is only the beginning. The next mystery might already be on its way.